Okay, so the title is kind of hyperbolic. The quote unquote best Ruby web framework is maybe overstating it. It's also slightly inaccurate, as Rack technically isn't a web framework, it's a web server interface. But I still kind of stand by those words. Rack is pretty awesome, especially compared to other more mature frameworks out there. In my first tutorial, I already explored using Rack in a practical sense. That is, instead of coding and developing the Rails way, I built an entire web resource in Rack. But I wanted to devote some extra time to Rack to really delve into what makes it great. So that's what this is, or rather, my attempt at it. So, what is Rack? Rack is a web server interface that nearly all Ruby web frameworks use under the hood, including Rails, Sinatra, Rhoda, Hanami, and many others. And yet, not many Ruby developers develop for Rack or know how to do so. So, what does that mean, web server interface? Rack allows for web servers like Falcon, Puma, etc. to talk to your web application through a simple, easy API. And because all these web frameworks like Rails and Rhoda are built atop Rack, they can all communicate with those web servers as well. And yes, the API is quite simple. One of the many reasons I developed for Rack is the simplicity of its interface. A Rack application can be any Ruby object that responds to call. This includes a class with a call method, or maybe a proc or lambda. And this call method accepts one argument, an env or environment hash, which then returns an array of three things: an integer of its status code, a hash of headers, and an array of strings, i.e. the body or payload of the response. Now, I'm the kind of developer who likes code to be explicit. With web frameworks like Rails or Rhoda, the mechanics of the web, or HTTP, like headers and status codes, are obfuscated from the developer. This sort of thing is called magic, which I think is apt because magic or magic tricks, they're more about deceptively hiding things in order to achieve a specific result than conveying intent. Much better, I think, to leave these details open and transparent, ready for inspection, though I suppose this may increase the amount of boilerplate. All right, let's create a simple Hello World application. Yes, we already did this in my other tutorial, but still. We don't have a folder here, so let's go create one. And we'll cd into it. And let's go ahead and create our project skeleton. Let me initialize the Git repository first. And then let's go ahead and add our README. Rack hello. All right, that's done. And we can commit that. Let's also set up the rest of our project. We're going to need a gem file. Let's leave that right now. Actually, we do want to add rack, of course. We also want a git ignore file. Let's just add some files that I like to ignore. All right. And then we'll add an install gems script. I think I'll just copy and paste this one over. And chmod it. Okay. And then I will add a load path. I'll also copy and paste this one. Okay. And then an init, which will require the load path. And I guess we'll require the rack hello directory or file. Yeah, I think I'm okay with this. After that, we're going to want a test script. And this will also be copied and pasted from another project. I'm just creating a project skeleton. And then I think we can use Atom for the rest of this. So let's add this project. Rack hello. Okay. One more thing we'll need is a license and a test directory. Okay, everything here looks good. So I'm going to add all of this as a part of a project skeleton. Now let's go ahead and create a hello world application. And for that, we're going to need a config.ru file, which is a rackup file. We're going to create an application class. This will look a little familiar if you looked at if you watched my other tutorial. So we need an env variable with our call method, and we can just return a basic hello world response. And this is just your basic rack app. Okay, let's run application.new. And here, let's clear this out. I believe, well, first we're going to have to install the gems. So let's do that. So we've installed the gems. I believe we can just call bundle exec rackup. So I'm not using a web server like Falcon or Puma yet, just because I don't need to. So let's go ahead and curl here to our rack app. All right, so we can see a hello world payload. Content type is text HTML like we set, and the HTTP status code was 200. So that's our hello world app. Let's go ahead and close that, and I guess we can commit that to our repository. Yes. Commit hello world application. Next, we want to talk about middleware. Middleware are components that stand in between the web server and the application. They intercept the request and do something with that request. Then they pass it on to the next middleware in the stack until it finally comes to the application itself. You can think of it like a stack of plates, I suppose. Each middleware layer can be a small, concrete piece, a single stage in your request response cycle. So for example, you might have data parsing and validation, authentication, logging, etc. Let's see a basic example for now. So we've got our application. Let's create a middleware. So each middleware will have an initialization constructor where it accepts app. And what you typically do is you save it. And what this represents is the next layer or the next, either the next middleware or the application itself. And we can see that so later on. So let's define our call method with our env hash. And here's what most middleware does. We take the response from the next middleware or application by passing in the env. And here are the hooks where you can manipulate or do things. You can do things before you call the next piece of middleware, so that would be your before hook. You can do things after you call the next middleware, which is your after hook. You can also update the env variable before passing it into the next middleware. There's a lot of things, and this is incredibly flexible. So if you want to see, we can do some sort of logging. So let's print out the start time, time.now, and we can also print out the end time, time.now. And let's go ahead and see what that looks like. So let's go ahead and curl. So we see the same response, but if we go to our web server, oh. All right. So I can kind of see, I know where I went wrong. I actually didn't run the middleware. So let's go ahead and do that. And we run middleware by saying use middleware. All right, let's try that again. You're seeing this error because there are exceptions. Oh, I know what happened. Our middleware needs to actually respond with a result, with the response that came from the next middleware. Otherwise, it just assumes that there was no response, because the response needs to come in this form. And if it doesn't come in this form, then it assumes something happened. All right, that should be the end of those errors. Let's try this. Let's clear this out. Try this again. Okay, yes. We see 200 response. We see hello world. Okay. Yes, and here we see that the start time was here and the end time was here. We don't really see it because we haven't printed out any milliseconds, but you get the idea. And you can see how incredibly powerful this is. All right, let's go ahead and commit this. Yes. Git add middleware. Now, for our basic routing needs, we can use the map method, which basically looks like this. So we can have foo and run some sort of, it's basically the same syntax. We just run another rack application. So what does that look like? So let's say we have our class foo, and we call, and we do something very similar, but we just say in the body, instead of hello world, we say hello foo. Okay. So let's run that. Let's clear this out. And let's go ahead and curl our root address again. It still works. We got hello world. And if we curl foo, we see hello foo. So that's basic routing. But for more sophisticated routing, I like to use the router library that I built and showcased on the earlier tutorial. Let's go ahead, and before we demonstrate that, I want to go ahead and commit this. Yes. Routing with map method. Now for that, to demonstrate to use the router, we need to download it from the path, and then we can install gems. And since things are getting a little more complicated, I'm not sure we want to keep things in the config.rackup file. So let's add it here. So let's say require rack, require router, and we can delete all this and create a rack hello directory. And I guess have an application here. Okay, the way it works is that we include a router module and define our routes like this. And then we can say route. And we could just return a basic rack response. Hello world with router. Okay, let's try that out. Oh, I need to run run this application. So let's say run application.new. Well, actually I need to require relative init run app. Ooh, technical difficulties. Not my favorite. Ah, I see what happened. Bundler standalone loader. Uninitial. Oh, right. Okay. We're almost there. Require application. Whoopsie. Rack. Hello application. Of course. There we go. And we can hello world with router. Yes, it works. All right. Let me go ahead and commit this. Router. All right, so here I've demonstrated the basic router, okay, but there's a lot more you can do with it. So we have our root method here. We could do things like say one of the nice things about this API that I totally stole from Rhoda is that you can use a nested routing tree. Okay, so what does that mean? So let's say you have your root method here. You could say on foo. So let's change this to hello foo. You can also define your get. So let's do that. And you can also define post. Okay. So let's see what that's like. So we don't have, we don't have a root, but we do have foo. So hello foo with router. But we can also do a post. Okay, I think this is happening because I don't have any data that I'm sending. So let's go ahead and pass some in. All right, cool. So we see hello foo with post. All right, but we can do even more. Say we want to do bar. And then let's change this to bar. Let's close that down and try again. And change this to bar. Yeah, we see hello bar with post. And if we try just a normal get request, we see hello bar with router. But even better is that I can define, say, a variable here, something like foo equals bar, and it can be used all the way nested over here. And let's try that out. As you can see, hello bar exclamation point with router is returned. Even though, so you can say, you can see that something like, say, if we're doing user checks or user validation, that can be something that goes in there, and that would be applied into anything that is nested down below. And with this syntax, you also get you can also get where is it? Here we go. Let's say we want to read an input. Sorry, I'm having trouble typing. Okay, here we go. And so we can say, let's try make text HTML. Hello input. Let's go ahead and try that. So what does that look like? Unexpected end. Oopsie. Oh, I see what's going on. Okay. Okay, that looks good. So what we're saying is we want to read whatever this is right here after the input directory. And you can see it reads the whatever was in that path. ASDF, ASDF. Cool, right? All right. Let's go ahead and commit this change here. Router further demonstrated. Now the question you may be asking, how do we test a rack application? Well, it's a lot easier than with other web frameworks, and without needing to use expensive end-to-end testing frameworks, or like, having to marshal a ton of resources like controllers and so on and so forth. That's because a rack application follows a specific API. And with this contract, we can do pretty easy automated testing. So let's look at that. First, we're going to need to install our test framework, which I like to use Test Bench. So we're going to use that. And then I'm going to install those gems. All right, looks like it was installed. So how do we do this? Let's go ahead. Let's go ahead and write a hello world test. So we need to require automated init. What we need is our application, which is pretty easy because we have it defined. And we need to have an env or environment hash created for us. Well, what do I like to do? What I like to do is have a control here that defines it for us, so I don't have to keep on generating it for each test. And of course, I'm going to need to require controls here in our test init file. So then I'm going to need rack hello controls, and I want a request. Let's go ahead and just do module controls, module request, and we just want a basic get request. So we'll do module get and define what that looks like for us. And yeah, okay. All right, so basically we want an env hash. So basically it's a hash. And we return that. But is that it? No. We want to have a specific path. And looking at the spec will help with this. This can all be found here on the spec document. So we needed a path, so we need to define it here. And this will look like this, like our root path or maybe foo. But right now we'll just pass it in. We'll have a default root. And then we want our script name. We'll just leave this as an empty string. And the request method is very important that we set, and that will be get. And then of course we're going to need our input stream, which here is defined as rack.input. And we can set that as a string IO. So once we have this, we can get the request. And we'll have a root. And then we need to parse the response. What I like to do here is also just set a couple of default parsers. Here we go, module parse. And then we'll want the status. And we'll want the header and the body. And the way we parse each of these is different, but we're going to want to call it with the response that we pass in. And remember, it's an array of 3 things. The first one is the status, and it's just an integer. And the header is the second one. And we're going to want to pass in a key so we can test the different keys. And with the body, we're going to have to do something a little bit different. Here, we get the body, which is the third element, and then we're going to have to join each of these. So we'll do body dot join, and that should be correct. All right. So in our hello world test, we can get the response by saying response equals app call with the request, and then we test status. So we get status through our controls, and then we assert that the status equals 200. Okay, let's actually test that. Oh wait, we need to chmod our test script. Okay, our parse file is incorrect. Oops, right. Self. Okay. Now the problem here is that we don't actually have a root method for our application. So let's define one. All right. r.is, and we're just going to say 200 content type text HTML. Hello world. Okay. Let's go ahead and test this. And it passed because the HTTP status code that we're sending back is 200, as we can see in our application. And then I think all of these other tests pretty much become easy. So we test headers, and we get our header response, and we want to test the content type header and assert that this header equals text HTML. Let's go ahead and test that test. Yep, that passes. Status and headers. And then for the body, we'll get the body. We'll parse the body from our response, and we'll assert that the body equals hello world. I believe that's what we set. Hello world, yes. And all three tests passed. So automated testing with Rack is pretty easy. Still, I like to do most of my testing of Rack applications through manual interactive testing. That is through testing by hand. This is because most of my Rack applications are small and simple. Let's go ahead, testing demonstrated. So most of my Rack applications are small and simple. They don't have a lot of dependencies. They aren't one cog in a huge interconnected machine. And therefore, changing one thing in my Rack applications won't really have very many downstream effects. But the option for automated testing is there if that is the case. And of course, if we want to test posts, we can do that, of course, too. And I'll leave that as an exercise for you to do, but it's not that much more difficult. So that's just a brief overview of Rack and its capabilities. And I hope I've convinced you, even if only a little bit, that you should at least learn more about Rack. It's got a fairly simple API, but it's flexible enough that it can handle any size application, as can be attested by the multiple varied frameworks built atop of it. And I think it's pretty neat. Okay, that's it for now. As always, if you have questions for me, be sure to check out my website, josephchoe.com, or message me on whatever social network of the day is, Twitter, GitHub, and so on. Thanks muchly.